Cool. So, hi everyone. Thanks for having me. Before we jump in, I owe an apology to Ofer from Amdocs, who asked me to speak today, and he asked me if I'm a good speaker or brilliant speaker. So I said brilliant. I'm sorry, I lied. But the good news is he's speaking today at 4, so maybe we'll do a survey later. Um, what we'll be doing today is intentionally not be focusing on the machine learning part, the mechanics, the technicalities of what we're doing, but look more on how AI is changing a whole business and how that business relates to each and every one of us. Before we dive in, let's answer the question on everyone's mind. Why am I sporting this great mustache that you're all very jealous of? There's a foundation called Movember, or a movement called Movember, which stands for Mustache November, with the goal of raising awareness for men's health. And at Augury, we're doing our small part, helping them. And at Augury, we'll talk about it in a second, we're part of the predictive maintenance world. And this is very similar, right? We look a lot at fault statistics and whatnot. And it turns out that prostate cancer, which is the second leading type of cancer in men diagnosed, has if you detect it early enough, right, you can go from 26 or 28% survival rate to 98%, right? So if I do one thing today, and that is help or push 5 of you to go and get tested, then I've done my job. If you want to donate to this foundation, you have a link over there. Augury will match your donation, and it's not a nonprofit foundation. Everything goes into research for men's health and increasing awareness. So let's talk about real problems, right? August 5th of last year in New Orleans, the sky opened up and 10 inches of rain fell within 3 hours. The result of that is what you see in this picture. Over 50,000 people were evacuated from their homes. Estimates are that roughly 1 million people were affected by financial damage that was done or disruption to their lives. And unlike Katrina, that was 5 or 6 years before that, this could have been prevented. The only reason that this flood happened is that the whole pumping system for New Orleans is basically 5 critical pumps. And their job is to take the water from the streets and push them or pump them into the ocean. And out of those 5 pumps, 3 of them were down for maintenance or they had mechanical issues. And during the flood, the 4th one also stopped working. So there was 1 out of 5 pumps that were supporting the whole city, and this happened. Now, when you think about it, in almost everything we do in life, right, from running water, electricity, the clothes we wear, the food and drinks that we consume, we all rely on machines to live our lives. And our goal at Augury is to make them better. We are here to make machines more reliable. Now, the market we're in, the facility operations market or maintenance market, if you will, has been on this journey that you see here, starting all the way back with reactive maintenance, which basically means you wait until the machine blows up and then you replace it, through preventive maintenance, which is what you typically do in your car, right? Every 10,000 miles or every year, you replace the belts, the oil, the bearing, the wheels or whatnot. And then in the early 90s, we started to see predictive maintenance emerge. And the goal of predictive maintenance, which is also called condition-based maintenance, is instead of replacing everything every year, why not check the condition, right, before you actually do it? And then what you would find is maybe you don't need to replace that belt. Maybe you can keep on running for half a year and extend the life of the spare part or the machine itself. Or maybe if you check more frequently, you would catch a malfunction before it happens, right? And then you can avoid the catastrophe. Now, to this very day, even though it's been done for almost 30 years now, it's a very manual process. So it relies on human experts that go out to the field with very expensive tools, take a recording, and then they go back to the office in order to manually diagnose the health of the machine. And today, we're standing in the intersection of these two megatrends. The first is the IoT, connected devices, low power, um, fairly inexpensive connectivity. And then on the other side, we have AI, right? If you look at the gains in the last 5 years, it's a quantum leap of what we're able to do, partly due to the help of this organization. And what this would enable us to do, if you tie it back to predictive maintenance, is enable to really have predictive maintenance widespread at scale, right? And this will enable our customers to move from looking at optimizing maintenance and uptime to focusing on what really matters, which is business growth and impact. So in a sense, we're helping the market move from the old way of doing things, which is a lot of firefighting and gut-based decision-making, to the Augury way, where you take a couple of sensors, you put them on the machine, and now you have full visibility to the health of your facility. And in the case of our customers, which are mostly global corporations, Fortune 500s, we enable them to build this control tower, right? Where all the data and insights come to them, and they can make really informed decisions versus the black box they have today. So how does it work? We take these blue boxes, endpoints basically, and we put them on the machines, right? Each one of these endpoints has vibration, ultrasound, temperature, and a magnetic sensor that measures the magnetic flux from the motor. And we connect them to the internet, and now we can provide ongoing alerts if anything happens or goes wrong. You can pass it on. Now, once we have the data, it goes through 3 stages of diagnostics. The first is anomaly detection, where we build a specific model or baseline for every single machine that we monitor. And naively, it sounds fairly simple, but if you look at a machine in the industrial world, it goes through various operating conditions, operational conditions throughout the day. So if you take 2 recordings of the same machine, they may look very different, but it's still in an acceptable condition. And after we build this baseline, we can tell you something has changed, even though we don't know what it is yet, right? Now, the next step is fault detection or fault analysis, where we compare your machine to all the other machines we've seen around the world. And now we can tell you very specifically, you need to replace your bearing, you need to replace your bearing, or you need to align the motor or whatnot. The last step is expert verification. What we found out is that if the recommendation is for you to replace a $200,000 motor, you want to hear it from a human being and not from an app. So we have vibration experts, reliability engineers that are always available for the customer if they request any further analysis. They also work with our algorithm team or data science team in order to help them develop the right models and select the right features and whatnot. And to date, we've diagnosed over 35,000 machines across mostly the US, Canada. We do have presence in Europe and South America as well. And as we work with more and more of our customers and partners, the amount of data we collect grows exponentially. Right? So to date, we've diagnosed over 2.5 million machine recordings. Each one of these machine recordings is a holistic view of the machine with up to 16 different sensors that we include in it. And our goal is to hit the 10 million mark next year. Now, just an example of what the output looks like, right? So on one hand, we provide a very nice and easy to read trend. Your machine is green, yellow, orange, or red, in danger. In this case, we alerted them on a misalignment. And when they opened the shaft, the coupling basically fell apart in their hands. Another nice example, here you can see the more specific actionable recommendations we tell them. You can see here, you have bearing wear on the driven fan driven end, so specifically which bearing it is. And then you need to check bearings lubrication if required and continue monitoring. After a while, when they replaced the bearing as part of their regular maintenance, they saw physical damage to it. So this is the mechanical side of things, how does it affect us, right? So this is an example I really like. It's with the largest brewery in the world. I can't name it on video. And this is we detected severe bearing wear on one of their more critical machines, the machine that's in charge of filling the cans with beer, right? And before this, because this is a 24/7 facility, they can't afford to take down the line, right? So every 2 months, they have a planned downtime window where they do all of the maintenance tasks and repairs that are needed. And we enable them to fix this machine as part of that planned shutdown. Now, had they not known about it, it would have caused them to lose the machine for the whole shift, which translates to close to 1 million cans of beer, right? And obviously nobody wants to see that go down the drain. But Bill, who is in charge of running this production line, he can't afford to lose 1 million cans. It affects the warehousing, the supply chain. It may even get all the way to the retailer at the end of the chain. Another good example is in a very large diaper manufacturer. If you have or had kids, you probably know them or use their products. And here it's an example of anomaly detection, right? So this machine is huge. It's from that side of the room all the way to this column here. And we were installed on 11 different motors that run it. Now, we haven't seen this machine before, so we couldn't tell them exactly or specifically what's wrong with it. But we did detect anomalies, right? Abnormal behavior. And when we worked with the process engineers, they told us, yeah, over here in the beginning, we manufactured size 4 diapers. When we shifted to size 5, configured it to size 5, we started to see vibration levels pick up, right? When they then shifted to size 3 and 4, everything went back to normal. And what we did, we enabled them to find the root cause of the issue. So they knew where to look. When they opened the size 5 rolling element, the gear broke off the shaft, as you can see. Now, if that would have happened during the runtime of the machine, the collateral damage would have been immense. So they were obviously happy with the results. Now we expanded to multiple facilities with them. So what does it mean for the industry, right? It's more than just detecting malfunctions in a machine or the ability to know before it happens. It's about shifting how they look at their business. And it all started in the early 1990s when GE and Rolls-Royce both stopped selling jet engines and started selling flight hours. Now, the reason for them to do that is that roughly 70% of the profit in these markets is in aftermarket, in parts, labor, services, and they want to increase the reach, right? Now, the flip side of this model, which is like a leasing model, is that they hold all of the risk. If anything goes wrong, it comes out of their pocket. And they need a way to minimize that risk by using predictive maintenance and technology like what we provide them at Augury. And when we work with these OEMs, manufacturers of these machines, it could be a pump manufacturer, a fan, chiller, or even a bottling line manufacturer or other segments in the industry, we try to help them move from where they are today, where the assets are not connected, to retrofitting using our existing solution, putting our sensors on the existing install base, and then eventually, in the next couple of years, embed the diagnostics into their machines. So every new pump would come connected with onboard diagnostics. When you look at their existing value chain, one of the largest pump manufacturers that is now our partner told us that they only know where 4% of their pumps are. They sell them to a distributor who sells them to an aftermarket parts supplier, sells them to the service company, and they lose track. They don't know where the pump is, what it's doing, how their customer is actually using it, and what faults they have more of. And our goal is to help them have a direct access to the end user, right? And then all the rest of the players would fall into this ecosystem. And this is only the beginning, right? As I said earlier, their goal is to sell water as a service. How do they move from selling pumps to selling charging by the gallon? right? And we're seeing this shift in the whole industry, not just in the equipment side, in the OEM side. It's called the outcome economy, right? It's very similar to what we had in the 90s, moving from selling software to software as a service. We're seeing the same shifts going here. In the insurance market, it's called UBI, usage-based insurance, from selling a annual premium that is fixed to changing it in real time based on the condition and the usage of the machine. And we're working with Munich Re, which is the largest reinsurer in the world, on getting to that outcome as well. So we're seeing this market evolve, and the holy grail is having it be autonomous, right? Not just being able to bill per usage, but also make changes on the fly. If I see a malfunction coming, maybe I can change the operations of the machine in order to avoid it altogether. So in a sense, we're building this central nervous system of the IoT, right, Internet of Things, with the goal of providing the right insight to the right person at the right time. Now, you could imagine we detect a malfunction in a pump, right? We notify the building manager on his iPhone or Android or her. They order spare parts by clicking on a button. They call in the service technician, who could be an employee of a different company, by clicking a button. If it's under warranty, we tell the OEM, the manufacturer. If not, we notify the insurance company. So what we're trying to do is really tie in all these different players and enable them to move from where they are today, which is using a lot of pen and paper and maybe spreadsheets at best, to having a fully automated solution where instead of the facility manager calling the distributor for spare parts, we can order them in advance. And we can tell the technician to be there, and we can tell the OEM if it's under warranty to fix it. And today we're working with the largest players in each and every one of these roles with the goal of getting to this future. So I see that I actually finished a bit early, so I can go into kind of the more technical side of things, unless you have any questions you want to. Yeah.
Just a quick question. So it's clear to me how you collect the information, whether there's an anomaly, your baseline measurements, and everything outside of it. How do you interact with your customers to get the data on what the specific fault was?
So we already have a lot of examples. Out of those 30, so we have, let's say 35,000 machines. Out of them, 1/3 had a malfunction. So we have 10,000 examples of what different malfunctions look like and behave like.
When you move into a new type of machine, is that just an interaction with the customer?
Correct.
Give you access?
So yes, in some cases, because as I said, predictive maintenance has been done for over 30 years, there are machine doctors, right? They know how to look at the data, vibration experts, and tell you what's wrong. We have 4 of them on staff, and they help us build the model, right? The chase for what we call the ground truth is always there, right? What happens if they're wrong, right? If the doctor is wrong. So we work with 20 external vibration analysts and try to kind of, and we send the same recording to multiple, and then we try to see correlation and whatnot to get to the, or we talk to the customer in some cases where we have access.
Yeah, I have 2 questions.
Yeah.
First one is, with your diagnostic tools, what's inside of it, what sensors, and where do you plug it into the motor? That's question number 1. Number 2 would be, in hindsight, what would you have done to say that put the pump in your lanes from going back?
Well, so each one of these endpoints has 4 different types of sensors. It has a triaxial vibration sensor, so we measure the 3 axes of movement. It has an ultrasound, temperature, and a magnetic sensor that measures magnetic flux or emissions from the motor itself. And then we can detect electrical faults in the motor. We don't plug it into anything. We simply come and epoxy it with a mount to the external shell of the motor. So it's non-invasive. In some cases, you don't even need to stop the machine from working. You just come in, pop the sensors, scan a QR code, and you're good to go. Regarding the second question, this has been done, predictive maintenance has been done for 30 years now. And there are studies made by the US Department of Energy There's a survey they did over 7 years, and they found that predictive maintenance can help eliminate 75% of all malfunctions. Right now, had the maintenance team in New Orleans, had they been doing predictive maintenance, probably all 4 malfunctions could have been avoided by simply looking and checking more frequently and using more advanced methods instead of just touching the machine and saying, oh, it seems okay. And that's where most of the market is today. Yeah.
Data protected, you have an encryption data, you collecting.
Yes, so we are a full stack company. We do everything from designing the sensors and manufacturing them through the connectivity, security, monitoring, diagnostics, and whatnot. So we have full control of the data flow. The data is encrypted from the endpoint. We have a special encryption chip on the endpoint, all the way to the server. And we also use standard Bluetooth encryption on top of it and the HTTPS and whatnot.
So is this really an IoT device?
In the sense that it connects to the internet, yes.
Right. And do you have other types of this device or just one standing?
For the continuous monitoring and diagnostic, this is our solution. And we are working on other different sensors that can feed into the same platform. Sorry, I didn't. Mm-hmm. Yes, yeah, I laugh that we add a new type of database every month to our stack. So we use every new thing that you read somewhere, our engineers plug it in, which is not always the best thing to do. We use streaming algorithms. Actually, maybe I have, I'm thinking if I have the diagram here. I'm not sure. No, so we use very much. So we use Apache Spark, and I'm trying to think of the Scala database for hosting the streaming data. Sorry. Mm-hmm. Mm-hmm. Yeah, so it has different stages, right? So we have this. So how do we handle the huge amount of data that we collect? And it is in the terabytes, right, that we're intaking. So it has obviously different stages, right? We start with the stream processing for the anomaly detection. Then we have the feature extraction that is used later on for research and more batch classification. Unfortunately, I don't have all the slides to go deeper into our technology stack today, but I hope that's good enough of an answer. Mm-hmm. Oh, on the server side. Okay, sorry. So you're asking about edge computing versus cloud. Okay, now I got you. So today we send all of the data to the cloud. We do have the capability to do some or even most of the anomaly detection on the edge. So the endpoint that you have here that we put on the machine connects to a gateway that we also design and control in the room. So they connect via Bluetooth, and then the gateway connects via Wi-Fi or cell connectivity to the cloud. Today, we shift all the data to the cloud for research purposes. But in the future, once we get to a certain threshold, we will start doing more of the anomaly detection on the node, on the gateway, and then we won't need to send all the data to the cloud. For us, it's more of a research investment, right? Like an R&D investment. So we are in the mechanical diagnostic side of things. We don't have an SLA of milliseconds to stop the machine before it explodes, right? We're here to detect degradation of mechanical failures that may take days, weeks, months even in some cases. So our SLAs don't talk about milliseconds. We do have a number of specific hours before we give a result. Our biggest bottleneck is the Bluetooth transmission. And yeah, so that's how we work. Yeah, so we have a gateway in the room that connects via Bluetooth. So we have the endpoints. They connect to a gateway via Bluetooth, and then the gateway connects to the internet via Wi-Fi, Ethernet, or cell connectivity.
So this device that you're showing, that's
Bluetooth, correct. BLE.
my question previously was how you get it at the same hour or
Mhm.
can you connect it to the internet?
So the term IoT stands for how do we connect things to the internet. There are a number of different methods, right? You can have mesh networks. You can have, we're not a mesh network. We are a peer-to-peer, a star network, right? There are different means of having a hub connecting multiple devices. This is our architecture, and I say it's part of the IoT, yeah, but that's how I see it.
How do you guys do continuous learning of learning that was a false alarm or
Mhm.
how do you do that?
So we have two different layers, as I said earlier, of diagnostics: anomaly detection and fault detection. For the fault detection, it's more of a batch type of learning. So we collect a lot of feedback from customers, from our experts, from external experts, and then every once in a while we retrain the algorithm, and we also our data scientists work on changing either the features or the architecture of the neural net or whatnot, and then we do it in batches, right? The anomaly detection is more real time. So we build a specific baseline for every machine, and if we see new types of statistics in the data, we always incorporate it into the model for that machine. So that's more stream. Any more questions? Cool, thank you very much.